Okay, hello everyone. So let's talk about 1.3. Chapter 1 is all about functions, and number 1 says use this table to see if the graph is linear or nonlinear. So if you notice, x is evenly spaced. I'm just adding 2 each time. And then for y also, I'm adding 2 each time. So let me show you how I came up with my answer for linear for number 1. And I actually said, does the data have a constant slope? So I calculated the slope, change in y over change in x, which was 2 each time, and so you get 1. So the key is to have those x values evenly spaced, and then you can apply the slope formula. Let's talk about number 3. Number 3 asks you to find the slope of the line that passes through these 2 points. That is y2 minus y1 all over x2 minus x1. So this is delta y and this is delta x. So I just labeled here for you x1, y1, x2, y2. So hopefully you can stare at this and see how I just inputted those values in for each function or for each number. Then I evaluate and I get 0 over 6. And that should check out because these two y values are the same. So that gives us a 0 slope, or like a horizontal line. All right, so number 5, and this one's framed a little different. They want you to find the slope of the line with f of 6 equaling -3 and f of -1/3 equaling -1/3. So let's translate this function notation into an ordered pair. X is 5, 6, y is -3. Similarly, there's the other point. We're supposed to find the slope, so again, we use delta y over delta x. And y2 I chose, looks like I did -1/3 minus -3, which gave 8/3, and then -1/3 minus 5, 6, which gave -7/6. And then I can take these two fractions, write the first fraction here, then multiply by the reciprocal of the denominator. So doing that, you get -16/7. And I just reminded you that if you have division of two fractions, that implies multiplication by the reciprocal or the denominator. And that's what I did here. Okay, notice this denominator was flipped and multiplied. And I did a little cross canceling there to help me compute. But you could do that in a calculator if you'd like. Okay, number 7. Here's an exercise where I'd like you to find the error. But let me show you how Pearson frames the question real quick. Number 7. Okay, so give it a moment as it loads. All right, so the number of visits to public libraries increased from 1.4 billion in 97 to 1.5 billion in 2002. Find the average rate of change in the number of public library visits from 97 to 2002. So when you hear the words average rate of change, you can think about that as slope. So that's basically all we're doing, but you've got to translate into x's and y's, which one is x's and which one is y. So here's a chance for you to stare at my work based off of that question. Where is the error? So if you want, you can pause the video and see, well, where did he make the error? This is called error analysis, and it's a higher order thinking skill. If you can point the error out, that means you probably understand what's going on. So I'm gonna let you find that on your own, but I'm gonna push on. So I did tell you that time should be your x value, which is a dependent variable, and the number of visits is your y variable, which is independent. And what actually happened was for some reason, I had switched my x's and y's. So that's the error. But anyway, I switched delta y and delta x. That was my issue. I was saying y was time when that wasn't the case. But anyway, so I just got this these two numbers here, and I did a little division the other way, which would be the correct way. So this would be delta y, and this would be delta x. And I got 0.02 billion visits per year. So again, if you wanted to pause that and see why that's the error, I did not write the ordered pair correctly, okay? I should have followed my structure here, but for some reason I just switched it. So don't do that. All right, let's go to number 9. Okay, find the slope and y-intercept. This one is close to mx plus b form. Hopefully you can notice the slope is the quantity in front of x, and then the y-intercept is the other number. So the slope would be -5/6, the y-intercept would be 6. For this one, again, if you want to see a more detailed explanation, you're welcome to click here. Okay, question 11. So here's another one using slope and y-intercept. This equation is in mx plus b form, or your slope-intercept form. So think about that for a minute. What would you say the slope is, and what is the y-intercept? The y-intercept is just where the graph hits the x-axis, or excuse me, y-axis. Okay, y-intercept. Now, let me show you my scratch work on this one, how I approached it. Okay, so here it is. Here's the equation, -9/5 x minus 8. I'm telling you m is the slope, which is -9/5. The y-intercept we can write as an ordered pair. X goes first, then y next. And I'm going to give you another chance to do error analysis. Here I said, well, why don't I just find the x-intercept graph? I don't want to count the slope. So I tried that out, and if you track with me, look at this equation here. Wherever there was a y, I just inputted a 0, and then I solved for x. So I'm going to tell you there's a small error here, and you should be able to find it pretty quickly. So pause the video for a moment, look at the mathematics and the algebra, and say, okay, what was the issue? So, all right, so really the issue is the x-intercept was incorrect, and it's -40/9, which is -4.4, which is not an integer. And so that's an issue when you're graphing by hand if you're just going by ones for your scale. So anyway, I'm like, all right, well, I guess I better graph this the way that they told me to. So you start with your y-intercept of 0, -8, and the slope, you can go up 9 and to the left 5. Okay, that is the same because the negative just traveled downstairs, and you're allowed to multiply a quantity by 1. Okay, and you can think, well, how does that work? But I could have also started from this point and went down 9 to the right 5. But I thought it would be more convenient to go up 9 and to the left 5. So keep that in mind for graphing slopes. All right, number 13. So this is an application question. I'll show you it in Pearson MyLab Math. Application of linear functions. I could see this happening in a business sphere if you want to figure out your numbers. So it talks about the costs of shirts. There's a fixed cost, and then there's a variable cost. Of course, the business owner is concerned about profit. So how much are they going to make? So your profit is going to be your revenue, what you bring in, minus your cost. Okay. All right, so we have Kara's custom tees. She has 300 fixed cost. Maybe that's a rental space, or maybe that's, anyway. Her variable costs are $3 a shirt. They want us to write an equation that can be used to find the total expenses encountered by Kara's custom tees. They're helping us out and telling us and defining our variables. Let X be the number of shirts. Okay, that's very important in any word problem to define your variables. And C of X be the total cost producing X shirts. And then lastly, once we get our function, they want us to calculate the cost of producing 7 shirts. So when I read the question, a strategy that I used to solve it is just to write down the important information from the question. Okay, so I said, all right, fixed costs are 300, variable costs are $3 per shirt. I wrote down X is the number of shirts, CX is the total cost of producing X shirts. So then the function would be 300 plus 3X. And now if I want to find the cost for making 7 shirts, I would just plug in 7 for X to get 321. Okay, so that's an application of linear functions. Okay, here's 1.4. Let me get my lab math up for this one, but while I'm doing that, just kind of stare at the screen, or better yet, pause the video and kind of see what's going on. And I'm going to go in and get my other screen that I need here. Okay, so I'm getting into the homework. Let me X out of this. All right, so now I'm going back to my homework assignment. And this is 1.4. Okay, question 1. All right, now I should be able to share this with you, provided that it loads up. I think it's going to load up here. Okay. Make sure we're on the right screen here. Yep, there it is, 1.4. Okay. So, we're supposed to write an equation for the line shown on the right. So here's the line. You're welcome to make it a little larger so you can see. Okay, so the y-intercept we can all see is 3. That's nice. We can count the slope. Go up 5, to the right 6. So the answer to the equation is here, 5, 6x plus 3. All right, number 3. Find the slope-intercept equation of the line that has the given characteristics. So they tell us the y-intercept and they give us the slope. So let me go tell you how I did this one for number 3. Okay, so I said m is slope of negative 11/7, b is my y-intercept. I started off with mx plus b form. Wherever there was an m, I substituted negative 11/7 x. Wherever there's a b, I replace negative 9. So that's it for that one. Okay, number 5 is interesting. Find the equation in standard form through the point negative 3, 1, having slope 0. So really, you could just jump right to the answer of, hey, y equals 1 because the slope is 0. You just get the y value, and that's the equation of the line. But I just wanted to tell you that ax plus by equals c is the standard form. And so I just used, it looks like I started off using mx plus b form. I knew the slope was 0, so I plugged that in. And the y-intercept, they didn't tell me that. So this equation did reduce to y equals b, but I kind of just jumped to it because I knew, well, hey, it's going to have a flat slope, so it has to go through this y value of 1. Anyway, so I got y equals 1 there. Another way you could have done it is just by writing it out here. It looks like I plugged in a 0 for a. And I mean, this just kind of helped me reason through, you know, why I could plug the 0 here. It's because it would reduce to the flat line case, y equals 1. Anyway, let's go back to my lab math real quick. And that was 5. I believe so. Okay, it's loading here. Let's give it a minute. Okay, so here it is. They give you multiple choice. If you want a different explanation of that, you're welcome to look here. Okay, number 7. Write equations of the horizontal and vertical lines that go through this point. So horizontal will always be y equals. And so because this is my y value, I write y equal -5. So that forces the vertical line to be x equals 7. So vertical lines are always x equal, horizontal lines are always y equal. Okay, moving on to number 9. Okay. Decide if the two lines are parallel, perpendicular, or neither. These ones actually end up being perpendicular because their slopes are negative reciprocals. And you probably will see my scratch work on that one later, but let's keep blasting forward here. Okay, this one's a little harder. We need to determine if the pairs of lines are parallel, perpendicular, or neither. So let me show you here how I worked this one out. Okay, so that's the one we just did. Here's the other one we just did. Okay, so 11. And so here's the equation: 2x plus 5y equals 7, and 5x plus 2y equals 10. If you look at those, notice all I did was I took the standard form equation and I solved for y to get the mx plus b form equation in both equations, okay? So, you know, I subtracted the 5x, divided everywhere by 2. Ooh, okay. Looks like I forgot to divide 10 over 2 here, but it actually doesn't matter for this question. I did a good job of dividing 5 here because, you know, I divided it by both quantities, but here would be another small error. And hopefully, if I was teaching this in a regular class setting, one of you would pop your hand up and say, wait a minute, aren't you supposed to divide 2 to each of these? And sure enough, yes, you are. Okay, anyway, that's kind of a tangent, but the point is we want to know, are the two lines parallel, perpendicular, or neither? So to do that, you need to examine slopes. And that's why I put standard form into mx plus b form. So for perpendicular test, I said, let's get each slope and multiply the slope and see if it equals -1. It actually doesn't. So they're not perpendicular. And then for the parallel case, are the slopes the same? And sure enough, they are different. So then it's not parallel. So that implies it's neither for number 11. Okay. So they'll actually make you find the slopes before you can say neither parallel nor perpendicular for your solution. Again, this one has a video, so you might want to take a look at that if you're a little confused, but I think most of you will be fine on this. Let's go to 13. Okay, are they perpendicular? Sure, they are. This is a completely vertical line, and that is a horizontal line, so the intersection would produce 90-degree angles all the way around, adding to 360. So yes, it is true. They are perpendicular. And make sure I'm on the right screen here. Okay, still on the right screen. So determine whether this scatter plot to the right is or can be modeled by a linear function. Yes, it can. I mean, you can just imagine a straight line going through. That's the easiest explanation. But notice the slope from the y-intercept here is -2 to the right 1. So the slope is -2 here each time. So yes, it's linear. Okay, going on to number 17. Find the standard equation of a circle having this center and this radius. So here's the correct answer. Let me tell you that you can view an example for this one. The circle equation is derived from the distance formula. I would show you that, but you're welcome to look it up on YouTube or Google how to derive the circle equation, and you'll get some good explanations of that. But let me show you what I did for this one. Okay, this is 13 if you wanted to glance at that. I actually graphed it. And 17. Okay, so I just identified the important information I'm telling you. The standard circle form is x minus h squared plus y minus k squared equaling r squared. So they told me the radius is 1/5, so I plugged that in for r. H is 4, and notice I keep the structure here of the equation. And then k is the second coordinate in the center. So this is h, this is k. So then wherever there's a k, I carefully put parentheses and substitute it in. And that's where the plus sign comes here. So the answer is D, x minus 4 squared plus y plus 7 squared equaling 1/25. So now let's go back to the homeworks here. I'm going to hit share. All right, so that's the homeworks. Again, you have so many resources for each of these. You know, view an example every time. There's also inside the textbook, I just want to show this to you real quick because there are other resources out there. You're not really required to do this, but I may use some of these videos to help you, but it's nice because you can get a video lesson on the section that you're working. So I'm going to click textbook here, and let me pull this up real fast. Let's do a new share. Yeah, let's get out of this real quick. Let me just X out. So just bear with me, and you will find a good resource. So let me make sure I'm sharing the right screen with you. Yeah, let's go desktop 1 and see what that does. Okay. So I'm here, and let me show you how to get to the book online. It's pretty cool. If you click on the chapter contents here, and then we were in chapter 1, we were looking at 1.4. So this gives you an idea, hey, I probably should, start thinking about budgeting some time for a chapter test coming up because we just finished the video on 1.4. Of course, you'd want to finish 1.1, 1.2, 1.3, and 1.4 homework. But I'm going to click on 1.4 because that's what we just did. Okay, and it's loading. And good, I'm glad you're seeing the same thing I am. And look at this, they have a video presentation, and you can also click here to read the actual textbook. But let me click this, and I'll show you just a little bit of the video here. If I can find the right screen. Maybe not. Hold on just a second. Okay, so there's a video for example 1, and it's loading. So anyway, be patient with these videos. It takes them a little time to load. Let me see if I can share this with you. Yeah, I think this is the one here. Okay, so there it is. And you can hit play.
We can determine equations of lines when we are given specific information about the line. In this example, we have the slope is equal to -7/9, and its y-intercept is 0.16. We can find the equation of the line using the slope-intercept form. Y equals mx plus b. Let's look at the given information in the.
Okay, so most of you can see, I'm just going to plug in -7/9 for the slope and then 16 for the y-intercept, and that'll be the answer. But I wanted to show you the online book has videos as well that will teach you. So there really are no excuses for, hey, I couldn't learn the material, because there's so many resources out there. Google.com is great, Khan Academy, YouTube. But anyway, I wanted to show you the online book and the good resource it is. So again, let me show you the screen where you can get to the online book. It's here. These are for a video lesson of the section, and that's the online book. So thank you for watching, and I appreciate your time, and go ahead and get started on that section or both of those sections, and have a good day. Thank you.